Okay, we are starting solving literal equations and formulas. This is part 1. This is actually the 5th and final learning target for Unit 2, Part 1, Solving Equations. So to start this unit or this section off, we do have a definition there, and I hope you are already starting to write that down. Your definition for literal equation is an equation that involves two or more variables. So some examples of that, you've already worked with this once before, but slope-intercept form, y equals mx plus b. That's actually an example of a literal equation. It does have more than one variable, so two or more variables are represented here, and a lot of times you'll know what m and b are, and so you're left with y and x, and you'll be able to graph that, which is a really important part of literal equations for Algebra 1. Literal equations with graphing, it's really important that you can solve for y. That way you can have multiple x values to plug in and be able to get your y value rather quickly so that you can plot and graph all of your coordinates. With formulas, when we get with formulas, those are really important in things like chemistry. If you've got a certain variable that you've got to plug multiple values in for, it's just much easier if you're able to simplify and solve literal equations. So what we're going to look at is we're going to start with one that you'll see most often with Algebra 1. We're going to take 3x plus y equals 10, and we're going to solve for y. So you're going to solve this very similar to how you solve all the equations we've done up to this point. Now, one thing that really confuses people is the two variables that you see there, but it's the 3 and the x here. A lot of people know, okay, I've got to get the y by itself, but what the heck do I do with this? Well, think of it like this. I'm going to go down here. I'm going to create myself like a little thought cloud down here. What if that didn't have an x on it? What if this were just 3 plus y equals 10? Well, hopefully, looking at this equation, this goes back to the very first video, hopefully you'd recognize this as just a one-step equation. And if I want y by itself, I've got a positive 3 here. Remember, this is understood to be positive 3 that I've got to move to the other side of the equal sign. So the inverse of a positive 3 would be a negative 3, and what you do to one side of your equal sign, you have to make sure that you do to the other. So if I'm going to subtract 3 from the left-hand side of my equal sign, I'd have to subtract 3 from the right-hand side, and that would solve your equation for y. So let's back up and use that same process for this literal equation. A lot of people want to jump in and try to start dividing here, and that's going to break your 3 and your x apart, which on some occasions would be necessary, but since we want y by itself, we want the x and the 3 to move as one term. We just want to move this all together. So this is understood to be a positive 3x. So the inverse of a positive 3x is simply a negative 3x. Very similar to what we did in our little thought cloud there. And again, what you do to one side of the equation, on the left-hand side of the equal sign here, I subtracted 3x. I have to go to the other side of my equal sign and subtract 3x. But I'm going to run into an issue here. This 10 does not have an x. There's not an x on this side at all. So I can't literally subtract 3x from 10. They're not like terms. So what I'm going to do, I'm not going to line them up here, because if I line these up, I may accidentally subtract when I'm not supposed to. I'm going to write my minus 3x kind of off to the side there. It's still on the right-hand side of this equation, of this equal sign, but it's not directly under the 10, so I don't mistake them as like terms, because they are not. So let's move back over here to the left-hand side. If I have a positive 3x minus 3x, that's going to give me the 0 that I need, and I'm left with a positive y. So since I have a positive y, I can just make that y equals, and again, I cannot literally subtract these two, So I'm just going to have to set up this algebraic expression here. Just write it the way you see it. 10 minus 3x. And there's your answer. We just solved that equation for y. Now again, like I said before, this comes in handy whenever you are trying to graph on a coordinate plane. If I were to give you a couple of values for x, if I were to tell you, one, that x is 1, and I want to know what's the y value. What's y going to be when x is 1? Well, that would be simple. You're just going to take your equation that you have here and plug 1 in for x. That's the value that you know. So I could write y equals 10 minus 3, and instead of an x, I'm going to put 1. And anytime you plug in numbers, we talked about this when checking equations, always use parentheses. So if you're using a calculator, you can just type this in your calculator exactly the way you see it, or hopefully you can do this without a calculator, following order of operations, doing your multiplication first before your subtraction. But what you will get is y will be 7. So when x is 1, y is 7. Very simple. I could give you another value. If x was 3. Well, again, just like we did here, instead of having a 1 for x, this time we're going to plug in a 3 for x. So to find y, 10 minus 3 times 3, you can type that in a calculator if you would like, or following order of operations, multiplication before subtraction. You will discover that y is 1. So it's much faster for you, if you've already solved for y once, to plug in multiple values for x and get a y value. Otherwise, every single time you're going to have to plug your 1 in and then solve for y, and then plug your 3 in and then solve for y. And so you'll be solving your equation multiple times for y. So with literal equations, solving literal equations, you solve it once, and then you can just start plugging in values for x. So what I would like for you to do, I'm going to give you an equation. 4 equals 2m minus 5n. And I would like for you to solve this equation for m. So go ahead and pause the video and try to solve that equation for m. Alright, hopefully you've got the right answer, so let's go through this equation and see how well you did. We want to solve for m. So what I'm going to do for this one, because I do actually have a coefficient of m in this problem, I'm going to highlight this. This is the variable that I want all by itself. So I do not want to touch the m. So let's move everything away from m. Let's analyze what's happening with m in this problem. Well, first of all, we're multiplying m by 2. And second of all, we're subtracting 5n. So if I were solving just a regular equation, if that n didn't exist, you could almost cover it up and forget about it. The very first thing you would have to do is, thinking back, following order of operations in reverse, very first thing we'd have to do is get rid of the subtraction part of this equation. So we have a negative 5n. We are subtracting 5n. So the inverse of subtracting 5n would be to add 5n. Now, just like on the last problem that we did together, I have to move to the other side of my equal sign and add 5n. But this 4 does not have an n. I cannot add 5n to this 4. So I'm going to write 5n or plus 5n kind of off to the side, not directly under the 4. That way I remember I can actually combine those. So going back over here to the right hand side, negative 5n, positive 5n, that gives me the 0 I need. So on this side of the equal sign, I do have just 2m left over. Now on the left hand side here, I have a positive 5n, and this is understood to be a positive 4. So there are multiple ways that you could write this. You could actually write this 4 plus 5n, or you could go the other way. You could take your positive 5n plus 4. Either way, it does not matter. I am actually going to write my n value first. Positive 5n and then a positive 4. Plus signs, positive signs. Those are interchangeable. They mean the same thing. Again, if you wrote 4 plus 5n, you still have the correct expression. And that equals 2m. Now, we're still not finished. Our m is still not by itself. So I'm going to go back and highlight this again. This is still not by itself. I have a 2 attached to it. Well, the 2 is attached by multiplication. Now, I'm not going to move the 2 and the m together like I did the 5 and the n. I don't want to move that m. I want it to stay all by itself. So I've got to leave it where it is. So this time is where I do actually have to break these two apart. So since this is attached by multiplication, the inverse of multiplying by 2 would be divide by 2. Now if I divide this side by 2, I have to go over here and divide this side by 2. And be very careful here. Don't make the mistake of only dividing the 5n or only dividing the 4 by 2. This entire side, just like this entire side, must be divided by 2. So to make that simple on yourself, just take the entire side, put it over 2. Divide everything on that side by 2. Now I'm going to clean this equation up a little bit. I'm not actually going to divide anything here. I'm just going to rewrite this as 5n plus 4 divided by 2. And that equals 2 divided by 2 gives me the 1 I need. So I'm left with m. So I have solved this equation for m. Here's my final answer. Now what I could do from here is I could give you several values of n, have you plug those in here, and give me the m. So in this equation it would be much easier on you to just plug in numbers. I could start at 1, go through 5, and solve for m, rather than having to plug in numbers in the original equation and plug in numbers for n and solve for m over and over and over again. So solving literal equations just makes things easier on you later on. Alright, I'm going to put up one more example. This is one that I want you to try. Ax minus bx equals c. Now I want you to solve that for x. So when you begin Literal Equations video part 2, we will look at how to solve this equation, but I want you to write this in your notes and go ahead and try to solve this before moving on to the next video.